Yeah, it's amazing who you meet at these things.
Eastview,
Johnny.
thanks.
The committee will come, of Energy and Climate will come to order. Welcome, everyone. We do have a quorum. We have minutes from the last meeting, and we have a lot of work to do. Representative Acomb, would you move the minutes from the last meeting?
Madam Chair, I move approval of the minutes from the January 15th meeting.
All in those in favor say aye.
Aye.
Any opposed? Minutes are approved. Members, we have many guests with us this morning, and Dr. Jessica Hellmann is going to be introducing them. Welcome, everyone. We are so pleased to have you. We had such good feedback from the hearing we had 2 days ago. People were interested. I was hearing about people watching us online, and I just want to let everybody know who is online that the slides that will be presented this morning have been posted on the committee website, and you can follow along with us. The committee website can be reached by going to the Minnesota House of Representatives and then looking for our committee, which is Energy and Climate. With that, Dr. Hellmann, welcome.
Thank you so much, Madam Chair, Gutknecht, esteemed committee members. My name is Jessica Hellmann. I direct the Institute on the Environment at the University of Minnesota, and I'm also a faculty member in the Department of Ecology, Evolution, and Behavior. And I, at the request of Chair Gutknecht, assembled the panel of presenters that you saw on Tuesday and that will continue again today. And I want to start by reiterating what I know you heard on Tuesday, and that's a big thank you for the opportunity to share our work with you and our insights. The University of Minnesota strives to provide excellence in education and research, and we're also here to serve the state of Minnesota and our legislators and decision makers. So thank you for that. Earlier this week, my colleagues, Drs. Mark Seeley, Tracy Twine, and Peter Reich were here, and they presented an overview of climate models and climate data, some climate projections, and a sense of general impacts across the state of Minnesota. And today we're going to delve into some sector-specific impacts, and we're going to discuss some strategies for addressing those impacts. So I have with me today actually 5 colleagues who will take part in today's presentation, and I will introduce each of them when it is their turn to present. And we've actually divided today into 2 parts, so we have 4 presenters for the first part and 2 presenters, including myself, in the second part. And we'll stop for Q&A in each of those 2 parts. And we're continuing on in the agenda that was shared with you on Tuesday. So for committee members, you have an annotated agenda, and we're on day 2. You also have in front of you the speaker slides with additional notes, including things like references and further information on points that will be raised and information that will be shared. And there's more detailed biographical information on each of the speakers in your notes. So the next section of our agenda, which will focus on sector-specific impacts in different key parts of the Minnesota economy, we'll talk about agriculture, then cities and towns, public health, and then lastly, natural resources in part 1 of today's presentation. So our first speaker is Dr. Jessica Gutknecht from the Department of Soil, Water, and Climate at the U.
Madam Chair and Committee, thank you. So I'm going to start today where Dr. Twine left off on Tuesday with some of the important climate changes that are of concern in our state. And I only have time to kind of briefly overview some of the agricultural impacts. And so as Dr. Hellmann mentioned, I have a lot more information in my slides, and I also am really happy to touch base with anyone if I don't cover something that's important to you or your constituents. And so for anyone who's been in a cornfield, I'm sure that your first question is, longer growing season, winter warming? Yes, please. I would love more time to get in all my work every year. Why is this a problem? Well, it actually really is a problem. The first problem is that if our winters aren't warm enough, the eggs of some of our pests will not die. And so this is demonstrated here where the kind of proportion of years for optimal conditions for corn rootworm are going to continue expanding hugely throughout this century. Conversely, our apples need cold winters. So without a sufficient dormancy period, orchard trees will have irregular flowering and fruit production. I'm now going to move to warmer summers. So this is first of concern to our livestock industry. It's been shown that as you increase the time of heat stress and the temperature of pigs goes up, their intake of food goes down. Just like us, when it's a hot day, we're not hungry, and it's the same for our livestock. This has major concerns both for yield decline and as well as health impacts. And this can be demonstrated for animals other than pigs as well. The other concern in warmer summers, and this is regardless of whether we have more of those kind of over 95-degree days that Professor Twine talked about, or whether our nighttime highs are higher, or our nighttime lows are higher, is that we'll see lower corn yields. And this is evidenced even by looking at the lower climate emissions models. And you can also see that this gets worse over time. Another interesting facet, though, of this figure is that you can see that here in Minnesota, we're actually in much better shape than some of our neighboring states. And that's a really interesting point moving forward that I'm going to come back to in just a moment. First, though, I want to take a slight sidestep from that and talk about extreme events and wet conditions. So across the US, we're seeing more and more land loss from these single-day extreme events. And this includes erosional losses here in Minnesota. And as you can see by this picture your picture on the right. Another big issue for us is an increase in disease with our wetter conditions. These are some images of corn rot from 2018, fall of last year, which was one of our wettest years. And one of our University of Minnesota Extension estimates was that the storage time for our corn after harvest was decreased up to 50% less of the time to be able to store grain before it goes to sale. So those are some of the impacts of our wet conditions. I'm now going to come back to this yield story. And now I'm going to talk about it in terms of volatility. And so if corn yield is volatile, it means that with any little increase in temperature, there's a really big decrease in yield. Whereas if yields are really stable, it means that with an increase in temperature, there's not a big decrease in yields. And you can see in those dark purple colors that actually in Minnesota, we have pretty stable yields compared to some of our neighboring states. And why is that? The reason is that we have beautiful, amazing soil. Our soil has a really high water holding capacity, and in this study, they found that this water holding capacity was one of the #1 factors of why we have stable yields. And this comes back to this point about erosion, because with our additional wetter climates, and if we start losing our soil, we lose this kind of buffer in our system. This also speaks to a point that Dr. Twine made about the need for more research. You saw a yield decline with temperature figure on Tuesday, and as I'm demonstrating, and as Dr. Reich and I both know very well, there's nuance to that data, and yet, we don't know exactly what's going to happen in our state. And so, as Dr. Twine talked about the need for regional models, we definitely need more regional, local information here in the state of Minnesota to know exactly how these things are going to play out. The other major impact on agriculture and climate change is the human factor. This is the yield anomaly map that you saw on Tuesday, and it parallels population loss in our state. As you can see, southern Minnesota at the top of that figure. Our farmers already face major challenges. I'm sure many of us already are very painfully aware of that. And we're going to be asking, under climate scenarios, even tougher questions of them. Am I going to have to buy an irrigation system that I only need every 3 years? Can I absorb this loss? Can I keep my farm? Like, this is what we're going to have to ask of our farmers, unfortunately. And this, decline in our rural communities, this urban-rural divide that we keep feeling, I fear is only going to get worse under climate change. And so that's the reality of the situation, the human aspect of the situation that we're facing. However, I think we have a lot of positives of what we can do. So I want to end on a ray of hope, not send everyone panicking. This looks like just a field, but it's a great story from one of the farmers that I work with up in Pine County. That green line in the back, he describes as being a river when he was a kid. And so they used to take inner tubes down that field in the springtime. And through the management and protection of his soil, he can now get into his field in the springtime and many times of year when his neighbors are completely flooded out. And so, if we choose to act, I think that there's actually a lot of great work we can do. Thank you.
Great. Thank you very much. Our next speaker is Dr. Bonnie Keeler from the Humphrey School for Public Affairs.
Madam Chair and members, as Dr. Hellmann said, I'm Bonnie Keeler. I work at the Center for Science, Technology, and Environmental Policy at the Humphrey School of Public Affairs, and I'm here to talk to you about the impacts of climate change on our cities and towns. So as many of our colleagues have mentioned, we expect to see increased temperatures and dew points that'll increase the number and severity of heat events. And this is especially problematic in our cities and towns because of the interactive effect of something called the urban heat island effect. And that's where we have concentrations of roads and buildings and pavement that increase the impact of extreme heat events in our cities because they absorb that heat and already are warming the temperatures of our cities above baseline relative to the surrounding areas that aren't affected by that same concentration of pavement and build material. So what we're seeing is these temperatures of heat, increased heat and dew points are also going to be greater in our cities even than they are in the surrounding area. And that means that we're going to have increased and overnight lows as well as the potential for increased dew points, which can lead to human health impacts. So we see the impacts of these changes in the temperatures of our cities in terms of increased energy demand, especially increased demand of energy for air conditioning, increase in heat-related illnesses, which will affect our elderly populations, and are especially problematic for communities and households that don't have access to air conditioning. There'll be negative potential effects with urban air quality as we see more air stagnation events, which happen in warmer climates, which means that air pollution, those reactions are also affected by warming temperatures. So we may have an interactive effect of stagnated air plus more concentrations of ozone, particulate matter in our environment that could lead to increased degradation of air quality in cities. There's also interactive effects with water quality within our urban areas. So our lakes and rivers and streams, as they see increased loads of nutrients and warmer temperatures, those are the right conditions to lead to harmful outbreaks of algal contaminants and sometimes some pests and pathogens. We expect to see decreased productivity for outdoor occupations. So if you're working in the construction, agriculture, mining, or forestry industry, our cities are going to be warmer, our dew points are going to be higher, and if we think about that combined with potential changes in air quality, that can lead to decreased productivity and health impacts for our outdoor workers. And then finally, material stress on our road pavements, bridge expansion joints, and railroad tracks. These are all expected impacts of increased frequency of extreme heat events. So if we look at what this looks like for just one Minnesota city, I live in southern Minnesota, so I picked Faribault. And this is the city these are the cities of our grandchildren. So by 2100, Faribault can expect an increase of 5 to 10 degrees in annual average temperature, an increase of 54 days above 95 degrees, 43 fewer days below freezing, and an increase in air conditioning demand by 300%. By the middle of the century, summertime conditions for Faribault are projected to be similar to the conditions currently felt over 500 miles or further to the south. That's the equivalent of moving the city 315 feet south every day. So if we think about what this means for the way that we plan and manage cities, whether we're talking about infrastructure, access to air conditioning, access to cooling centers, retrofitting of buildings, the way we manage our vegetation and our parks and green infrastructure, the water needs for irrigation in cities, the shifts in patterns of recreation, the productivity and safety of workers and kids who spend time outside in these cities, we're looking at very different conditions in our cities in the future. So in addition to heat, if we think about the increased frequency and intensity of precipitation events that others have mentioned, as we expect under a warming climate, this will also and has already had impacts on the infrastructure and safety of our cities. So this diagram here shows the equivalent volume of water associated with what we're calling a mega rain event. And we've had an increased incidence of these, if you look at the historical timeline of where we've seen these mega rain events, where we're seeing 6+ inches of rain falling in a relatively short period of time. You can see the extremely large volume of water that we're talking about when we think about these really intense precipitation events. So we already have failing, aging, deteriorating infrastructure, and estimates expect that that could cost US GDP as much as $3.9 trillion by 2025. And our current infrastructure and design standards don't take into account these future trends in climate change. So we're facing damage to transportation infrastructure, to property, and this will be especially problematic for our water and sewer systems, which then leads to an increased burden on emergency management and growing financial toll on businesses, homeowners, and insurers. So we have a variety of tools to try and understand the impacts of climate change on our cities, and I just wanted to point out one that's provided by the Met Council based on data generated by state agencies as well as University of Minnesota scientists, and this is a climate vulnerability assessment tool. You can look at both the impacts of flooding events as well as heat events within the Twin Cities. And this is just a map that shows areas of downtown St. Paul that are more vulnerable to flood events. So as we see these increased and these extreme precipitation events, we expect to see certain parts of our city and infrastructure be differentially affected by flooding. So these kind of maps allow us to identify regions of the city where we may have vulnerable infrastructure, homes, and neighborhoods, and start to think about how to mitigate those impacts. So finally, I just wanted to acknowledge the investments that have been made by state agencies and scientists to help us understand the impacts of climate change on our cities, and there's a lot of fantastic resources. Both the U.S. National Climate Assessment that was just released has impacts not only, chapter not only on the Midwest, but also on cities specifically. And Department of Health and MPCA have done some really nice reports that specifically look at the vulnerability of our cities to climate change and provide specific recommendations for certain cities, for different sectors about how to adapt to and mitigate the impacts of a warming climate. Thank you.
Great. Thank you, Dr. Keeler. Our third speaker is Dr. Laalitha Surapaneni from the Division of General Internal Medicine.
Madam Chair, committee members, thank you so much for this opportunity to talk about the health impacts of the damage we're doing to our climate. Climate change has been called the greatest global health threat of the 21st century. But a statement like that can be quite overwhelming and very depersonalizing. So I wanted to start my talk by showing you what climate change means to me. It's a 15-year-old kid who's playing on a hot summer day and ends up in the emergency room with a heat stroke. It's a child with asthma who's chronically absent from school and will never reach her full potential. It's Minnesotans who feel a sense of loss as they no longer recognize their land. And it's people who come to Minnesota as climate refugees, both from coastal cities in the United States and from countries elsewhere. Because at the end of the day, this is what climate change is all about. It's about us. It's about people. It's your neighbors, your friends, your families, and the people you represent. So with that, I wanted to show you the major health impacts that we're projected to face in Minnesota. Let's start with allergies. We've already heard testimony that the allergy season from ragweed pollen is increasing, and we're seeing a corresponding increase in the number of allergy cases. And this also ties into asthma. This is the current state of asthma in our state. We have an incidence of about 7%. Does anyone here have asthma or know someone who has asthma? Yes, and this is a big problem because climate change is projected to make this worse. I have just talked about how pollen can induce cases of allergic asthma, and then we've heard testimony that we'll see more wildfires, and so the smoke from wildfires will decrease air quality, which will also trigger asthma attacks. Then we're also projected to see an increase in the number of cases of mold, and I'll talk about that in my next slides. But the main thing is about air quality. In Minnesota right now, we have really good air quality, and the American Lung Association puts out a report every year about the state of our air, and Minnesotan towns and cities fall in the top 25 cleanest air cities. But with hotter days, we will see that the polluted air stagnates and all the air pollutants essentially bake together in the hot weather to form ozone, which can then trigger asthma attacks. Next is extreme heat. So we've heard testimony that we will see more extreme heat days, but what's even more interesting is that our risk perception of heat is very low. So think about all of those people, up north. I used to work in Bemidji. Most of the homes don't even have air conditioners. And so when you combine those things, elderly people living alone would be at highest risk for heat strokes. This is a slide on the worldwide burden of heat illness. So we are seeing that more and more people are being exposed to extreme heat, and correspondingly, we're seeing a drop-off in labor productivity, especially in workers like farmers and construction workers who work outdoors. We also heard just now that we will see more mega rain events. And so with that, we'll see homes that are chronically flooded, which will then lead to an increase in mold, which can act as a trigger for respiratory illnesses. And this is also an environmental justice issue, because who are the people who won't be able to afford a cleanup of mold or who won't be able to move? So this becomes a housing equity and justice issue. And then we have vector-borne illnesses. So these are tick-borne and mosquito-borne illnesses. We're seeing a rise in the number of Lyme disease cases and West Nile virus as well. So this is a close-up shot of Lyme disease in Minnesota. There's many reasons why Lyme disease is going up, and there's deforestation, urbanization, deer population. But one of the things that studies do notice is that when you have a warm and a wet winter, then the following summer we see a rise in tick activity. Then there's also impacts on mental health. So there's good evidence documenting PTSD after natural disasters. And we're also seeing some studies linking depression and suicide in farmers to drought in the Midwest. And this is actually an emerging area of research trying to figure out the impacts of climate change on day-to-day mental health. Then I also wanted to talk about how climate change will impact all of us, but those impacts are not distributed equally. Unfortunately, people who contribute the least to it sometimes end up bearing the brunt of these impacts. So low-income families, children, elderly, people of color seem to suffer most of these impacts. One of the studies done at the university show that people of color are exposed to 40% more polluted air than their Caucasian counterparts. This is unfair. We all have a right to clean air, clean water, and a stable climate, and we should work towards that. And I wanted to show you this declaration. This is all doctors across all specialties, nurses, we all agree that climate change is a right here, right now problem that's affecting the health of Americans. And I wanted to close with a slide of what climate action can look like. Thank you so much.
Thank you, Dr. Surapaneni. And our last speaker in this sort of sector-specific deep dive is Dr. Lee Frelich from the Center for Forest Ecology.
Okay, thank you, Madam Chair Gutknecht and the entire committee for inviting me here to testify today. So Minnesota is in a very unique position on the planet. We're one of only 2 places in the entire globe where in a mid-continental setting we have 3 biomes come together. The boreal forest, those are the cold forests of the far north dominated by conifers, the temperate deciduous forests, mostly maple, oak, and basswood, and prairies. So it's a really great place to live. And because we have these biomes and they're all edges, we are the edgiest state in the nation. Every species of tree, except for 2, has the edge of its range in Minnesota. These biomes have their edge in Minnesota. So we're going to be very sensitive to a changing climate. So I'll first talk about the boreal forest versus temperate, and then forest versus grassland. What is it about the climate that determines those boundaries? So it turns out that mean summer temperature, this would be the mean of June, July, and August, determines whether the boreal species like spruce and fir will grow more than temperate species like maple and oak. So if you have a mean summer temperature in the range of 63 or 64 degrees Fahrenheit, then the fir and spruce will outgrow the temperate species and you'll have a boreal forest. There's a tipping point right around 64 or 65 degrees, and when you get up to 66, then the temperate trees are going to take over. So if you look at a place like Duluth, a few years ago they were in the range where fir and spruce would grow more. Now they're at the tipping point, and in a few decades they'll be in a place where maple and oak will grow faster and therefore replace the boreal trees. And in our studies, throughout Minnesota, northern Wisconsin, and upper Michigan, we found already with the climate change that has occurred up to this time, there's already a major invasion of maple and oak into the boreal forest. As you see here, there's a picture of a maple tree, and 40 years ago when I worked in this forest, it was purely boreal. There were no temperate species at all. So the warming that's already occurred has already had a big impact. Looking at prairie versus forest, that you see here our original prairie forest border at the time of European settlement. And it turns out the balance between those 2 biomes is determined by the water balance. In other words, if there's more precipitation than evaporation, which are the green and blue areas on the map on the right, you get forests. If there's a negative water balance, so evaporation outstrips precipitation, then grasslands occur. I'll come back to that. You might ask the question, where is this negative balance going to move in a warmer climate? I'll come back to that in a couple of minutes. There are other things going on in a warming climate, especially more droughts that are stressful for trees. You've probably all seen the dead birch trees on Highway 61 on the North Shore. That is an impact of increasing drought frequency. We've seen a large increase in the occurrence of big forest fires and insect infestations in trees. Mountain pine beetle, for example, is limited by -40 minimum winter temperature. So when -40 goes away, the pine beetle can move in here, and they do or are capable of inhabiting our jack pine, red pine, and white pine in Minnesota. Emerald ash borer is another one of those insects that currently is limited to the southern part of the state and the part of the state near Lake Superior where it doesn't get as cold in the winter. The north central part of the state where most of our 1 billion ash trees live usually gets down to 30 or 35 below, and that's enough to kill the ash borer, but as the climate warms, it could move in there and kill most of our ash trees. Another feature of the warming climate is that we get these long warm spells and cold spells. For example, you might remember March of 2012 when it was 85 degrees in the middle of March. And even in the boundary waters, it was up to 80 degrees in March. And what does a boreal forest do with 80 degrees in March? Well, it dies because conifer trees just simply can't make use of that temperature. They come out of dormancy too early. So you see here a picture of thousands of square miles of spruce forest up near Thunder Bay that turned brown as a result of that early spring in 2012. So this complicated graph just makes the point that there's a lot of other things other than the direct impact of temperature and precipitation We have more deer in northern Minnesota in a warming climate, more fires, the earthworm invasion will increase, more droughts, more windstorms, and more insect pests. And those are 6 gas pedals that are all pushed on by a warmer climate. So it's not just the temperature, it's all these other factors as well. So if we go to northern Minnesota, we have the arboreal tree species here: birch, aspen, black and white spruce, red pine, jack pine, and balsam fir. Well, we might have to get a new state tree if red pine no longer grows in Minnesota, because with a business as usual carbon dioxide emission scenario, these are the species that will replace those trees in northern Minnesota. Things like basswood, bur oak, bitternut, hickory, Kentucky coffee tree, hackberry, and our 3 native elm species. To put that in pictures, if you look at the blue star here, which is the boundary waters, can we find a place that today has a climate similar to what the boundary waters will have, say, near the end of the century? And the answer is yes. Granite Falls, Minnesota, the orange star there, is about 8 degrees Fahrenheit warmer. So this is what the boundary waters looks like. This is a black spruce forest, one of those species likely to exit the state. And this next slide shows a site with the same type of rock, same physiography, same chemistry. It just has warmer summers. Nice outcrops, natural area near Granite Falls. And you can see the oaks there mixed with prairie plants. So we're talking about that versus that just by warming the temperature by several degrees during summer. And then you can superimpose all those other factors: the insects, the droughts, the storms, the fires, in addition to that. These maps show our most recent research at the Center for Forest Ecology, and it shows where biomes are today according to climate. So you have the blue, which is boreal forest. The green is mixed boreal and temperate. The very light yellow is the broadleaf temperate with maple and oak, and then you see the prairie way out there on the west. And then you see 2 alternative futures, one with a low emission scenario for greenhouse gases where we retain a little bit of boreal forest in northern Minnesota. But the one with the high emission scenario shows that the prairie would advance dramatically to the east. We would lose the boreal forest completely. And this is nowhere near the highest warming scenario that we could have. And this only takes into account temperature and precipitation, not those other 6 effects that I mentioned earlier, which could easily, by the year 2100, push the prairie forest border all the way to Grand Marais or Thunder Bay or even Cape Churchill, Manitoba on Hudson's Bay. And when you change the biome or the vegetation, you also change the wildlife. So this just shows a few examples. There are boreal species on top: lynx, moose, and blackback woodpecker, which in a warming climate, if the boreal biome were to disappear, would be replaced by these other species: bobcat, deer, and red-bellied woodpecker. And there are hundreds of other examples of that. So big changes are coming because of global warming, because we're on the edges of those biomes. For a business as usual scenario, we could literally be the new Kansas. And I don't know about you, but I didn't move to Kansas for a reason. There's a reason why I came to Minnesota, and I don't want Minnesota to be Kansas. The boreal forest is likely to disappear from the region, and that's 1/3 of all our native species. Trees, wildflowers, birds, insects, pollinators, every taxonomic group. There's still time to change the outcome for this future scenario, however, because with a low emission scenario, we could prevent that from happening. So thank you to the committee.
Thank you, Dr. Frelich. Madam Chair, this group of 4 would be very happy to answer some questions.
Representative Christensen.
Madam Chair, thank you. I have a question about the USDA zones that are put out. What is the data on those? How have those changed? I believe we here in the Twin Cities are in a zone 4 to 5. I'm just wondering how those zones have changed and how they've been affected by the climate.
Yes, Madam Chair Wagenius and members of the committee. We've gone up by one zone over the last several decades. So yeah, we can plant things in the Twin Cities. That's one positive side of global warming, is that there are some species we can plant here that we couldn't plant before because we do have a warmer zone. But we might go up 2 more. So we went from zone 4 to 5, and we might go to 6 or 7 in the future. Yeah, and there's good data on that. If you want the maps, I can find those maps for you. In fact, they're on my computer in my office.
It's predominantly.
Yes, it's based on minimum temperature.
Representative Long.
Thank you, Madam Chair. Dr. Frelich, I am struck by your slides on the boreal forest in northern Minnesota. I love going to the Boundary Waters. I have a newborn daughter who's 4 months old, and I'm hoping that she can take her children to the Boundary Waters to be able to see boreal forest as well. But it looks like that decision will be made in her lifetime, at least in the next 50 years. And the future biome distribution you have for northern Minnesota, the high emissions versus low emissions scenario. Can you explain a little bit what the difference is between those 2 scenarios in terms of emissions and what that would mean for keeping boreal forests in Minnesota over the next 50 years?
Certainly, yes. Madam Chair Wagenius and members of the committee, that's a great question. The difference in those 2 scenarios is whether we follow the Paris Accords strictly, we reduce our emissions by 80% or more, convert to renewable energy by 2050, and plant a lot of new trees around the world. If we do that, we could follow that low emission scenario, and we could retain some conifer forest in northern Minnesota. The other scenario was one of several so-called business as usual scenarios where we don't do anything about climate change. We just keep doing what we're doing now. And the one I showed was actually a very moderate one. And there are much worse scenarios that we could have for business as usual. So it's basically high emissions of greenhouse gases and not doing anything to curb those.
Madam Chair, Dr. Frelich, so the low emission scenario you have here is the 2 degrees IPCC
It's
target.
less than 2. It's probably 1.5
This
Celsius.
is the 1.5 degree.
Yeah, and the other one is 4 or 5 degrees for world mean temperature.
Business as usual. Thank you. Madam Chair, one more question. I have a question for Dr. Surapaneni. You note in your slide on the asthma burden that right now there's already a 4-time higher death rate among African Americans than whites in Minnesota. And that's under current scenarios. You also mentioned that ozone is going to increase the risk of asthma attacks.
Absolutely.
So is it fair to say that as the climate warms with current projections that our current disparities among death rates could get even worse?
Yeah, absolutely. So there's, with asthma, there's many factors that come together that ultimately result in deaths from asthma. But we do see that whenever we have hotter days, ozone concentrations go up, and studies show that there are more ER visits for asthma exacerbations. So, yes.
Representative Bierman.
Thank you, Madam Chair. Dr. Surapaneni, since you're up now, I did have a question on, you did a great job on the overview of the health effects and how that affects our workforce and jobs and et cetera. I'm wondering, with all the discussion we have on healthcare these days, I haven't seen any economic data on the effects of climate change being factored into the healthcare equation, and I'm wondering if there is such data. And
So that's a really good question, Madam Chair, committee members. So we do, healthcare contributes to 8% of greenhouse gas emissions in the U.S. And so there's many groups that are working together to both mitigate and also adapt. So we are working to make healthcare more sustainable and decrease our emissions, but at the same time, we also have to prepare for, protecting our infrastructure and workforce from, let's say, extreme weather events and planning for those, but at the same time, also plan for extreme heat, putting more people in the hospitals and more people coming in with asthma exacerbations, just like you would for, flu season. So, yeah.
Thank you. And also, for Professor Keeler, you spoke about the scenario of Faribault and some of the temperature rising issues there. And I'm just wondering, in some of the presentations, we've had a, best case, worst case scenario. And it seems as if as I observe climate issues, it seems like we're behind on those predictions of dates and things are happening faster than we expect. And I'm just wondering if that scenario you painted is sort of in the middle or where that stands.
Madam Chair and members, thanks for that question. So that scenario would be similar to the one that Dr. Frelich talked about with respect to business as usual.
Okay.
And when we talk about scenarios, it's a combination of many different factors and assumptions that go into these models that both think about the rate of economic growth as well as changes in our energy sector and industry that affect the rate of emissions. So there's a bunch of different factors that go into those different scenarios. And I think these give us a range of what our possible outcomes might look like under different scenarios in the future.
Thank you.
Madam Chair and Committee, I would add one thing as we're discussing healthcare impacts and these climate zones, just to remind you of the discussion that we had on Tuesday about the fact that, the Twin Cities and urban areas are actually warming faster. And so that's something to keep in mind with some of this discussion as well.
Representative Acomb.
Thank you, Madam Chair. So I have a comment and a question. First, my comment is, a few decades ago, I had Dr. Frelich as a student at the University of Minnesota. And in those classes, he was also talking about the boundary waters. And so I will just say I really appreciate his expertise and perspective on the forest ecology portion of our discussion this morning. My question, though, is for Professor Keeler, and it's around cities. And so I guess I'm asking about what size cities did you look at? And I know you talked about Faribault, but we have obviously a large diversity of city size in our state. So I'm curious what size cities you looked at.
Madam Chair and members, so the work that I cited is part of the climate assessment that was done contracted through the Minnesota Pollution Control Agency, MPCA, contracted to have climate vulnerability assessments done for 20 Minnesota cities. And so if you go to that website, you'll see 20 different cities that have all had that similar scenario evaluated for them. What you see if you look across those cities is actually a pretty consistent trend. So that's the stats that I showed for Faribault are not going to be that different for Duluth or for St. Louis Park or for Granite Falls or any number of other cities. What we're seeing is fairly consistent trends of lower, so higher low temperatures and then more extreme heat events or what we call very hot days, which would be anything over 95 degrees. What you see differently across the cities are that change in expected increase in air conditioning use, and that really varies based on the baseline amount of air conditioning within those different cities. So if you're in northern Minnesota and you don't have a high rate of adoption of air conditioning and you're expected to see these increased temperatures, you're going to see a much higher increase in energy consumption associated with air conditioning.
If I may follow up. You also talked about the climate vulnerability assessment tool. And so my question really is about our cities and counties, towns. Are they identifying the risks or the vulnerabilities that they have within their communities? And so are they identifying so that we can be working towards adaptation?
Yeah, Madam Chair and members, it's a great question, and I think what we see in Minnesota is we've done a lot of strategic thinking about this. There actually are tools and methods and data and reports out there available for cities right now. Whether or not those are being used in planning depends on the capacity of the staff and the interest of the municipalities in addressing those concerns. But I think we do have a pretty clear set of the potential impacts of the future that we're going to face, that cities are going to face. And a lot of that can be mitigated through zoning ordinances, through thinking about strategic investments in infrastructure, through updates to building codes. So we have tools available to us to help to anticipate some of the changes that we expect, but it's going to take planning and it's going to take resources.
Thank you.
Representative Mahoney.
Thank you, Madam Chair. And Dr. Frelich, just a comment, Kansas City has absolutely the best barbecue and one of the best classical music concerts out in the Flint Hills. So it does have some good parts to it. But my question is for I think it's Dr. Gutknecht and another one for Dr. Keeler. So Dr. Gutknecht, you spoke a lot about the agricultural piece to this. I spent some time on the Ag Committee and went through a little bit of the U of M's Ag Department's budget. They spend a ton of money on research, which is what you're supposed to do. Are there studies, are there crop studies about what we can grow that can supplant corn, soybeans? If I do believe, unfortunately, that the human race is not willing to make some of the sacrifices that are being asked of us to do. I just don't think we're there yet. And our farmers are pretty smart people. Do we have something for them to grow in 20 or 25 and 50 years?
Yeah, Madam Committee or Madam Chair and Committee, that's an excellent question. And I actually, as a soil scientist, have partnered a lot with some of those agronomy professors to look at multiple options for our farmers. So we are looking at, how do you grow what you already grow in a better way? Can you manage tillage or cover crops? Or, can you start small to test out the risk on your own farm? Can we grow perennial grain crops? That's another thing I'm specifically interested in. And an advantage of some of those is that we kind of get a double whammy as we do with like other perennials on the landscape of improving our soils as well as protecting our surface water and groundwater. And so that's another avenue that we've been looking at as an alternative crop. But also, something I think, as I mentioned at the end of my talk, that we need to keep in mind is the human aspect. So like the NRCS has some programs, there are other programs to assist farmers through these risks. And so I think we need to kind of keep that in mind as well. So we've really been tackling like, what's a myriad of ways that you can either grow what you already grow better, or can you grow something else, or can you diversify your cropping system so that you have lots of options. If you know that this year might play out in a certain way, what's the best strategy for you to use? And so I think that's going to be a shotgun approach of many options. And, depending on where in the state you live, you might have different needs on your farm as well. And so I think there are a lot of options out there that we kind of need to consider together.
Jason will speak to some.
Oh, right, and that's a great point. We're gonna, after this session, we're specifically having an adaptation session as well. So, so there are a lot of options, and we are researching a lot of those as well. We're actually putting a new field study in this year specifically to look at some of those things as well, so, yeah.
And then, Dr. Keeler? Two things. As a construction worker for 30 years, I've done my time in 105-degree temperatures at a refinery where it's actually 10 or 12 degrees warmer. And I managed to get my 8 hours in and done correctly. So human beings adapt, and temperatures are relative. All the folks from Texas and Louisiana that come up here laugh at us when we say it's too hot to work at 110 degrees. And I laugh at them when they come bundle up like a spaceman at 5 degrees above zero. So you talked about one of the things you talked about was the Minnesota Pollution Control Agency's research they did on how cities, could you share with the committee or through the committee administrator some of those studies that are broader based so that it's specifically for me, I kind of think of how our sewer and water systems are going to work because we bury everything at 5 or 6 feet because of frost heaving, that kind of stuff. How is our air conditioning systems going to work? It was 112-degree day was the day I came home with 4 bags of ice and put them in the ice in the bathtub and jumped in myself. And so anyhow, if you could share that with the committee administrator and the chair would instruct him to pass those along, I would appreciate it.
Madam Chair, would it be all right to move on to the second part of our presentation sometime soon, or do you have?
We're going to have one more question, and then we will have 3 folks on the list right after your next presentation. So we'll have Representative Hansen now, and then Representative Hornstein, Halverson, and Swazinski will be right after the next presentation. Representative Hansen.
Thank you, Madam Chair. And my question's for Dr. Frelich, and looking at kind of the green carbon sequestration. The state has the potential to be planting trees. We have a state nursery. And how do we sequester carbon with plants, with trees or native prairie? And maybe this is a question for the soils person as well. But we spend a lot of money in the state of Minnesota restoring habitat, purchasing property for unique habitat. And what I took from your presentation is that habitat is going to change. It's going to move. And so when we buy a property to save it, what we're saving may not be there in the future. So there's kind of 2 parts to this question. One, how do we adapt with our purchases and restoration when we're spending over $115 million a year roughly on that? And then what can we do looking at carbon sequestration with our purchases, like planting 1 million trees that are ecologically appropriate? What does that ecologically appropriate mean?
Mm-hmm. Yes, Madam Chair and members of the committee, that's a great question. We're doing a lot of work to answer those questions with regard to all the habitats that we are purchasing. They can always support a natural plant community and wildlife of some sort. It's going to change, but those are going to be really vital stepping stones as species move from habitat to go north, because most species move with the climate. So it's still important to have a lot of natural habitats that are protected, because those are the stepping stones for movement, especially in southern Minnesota where most of the landscape is agriculture. They're even more important there. With regard to sequestering carbon, yes, planting trees will sequester a lot of carbon if you're planting them on areas that used to be forest and were deforested, and now you're establishing new forest. But establishing restored grasslands can also sequester a lot of carbon. They can sequester over several decades as much carbon underground as you can get in an old growth forest above ground. So it's important to do both, and we need to look at what we're doing as part of a worldwide program. Worldwide, we need to plant an area of forest the size of the 48 states, and that in order to deal with this problem. And that might sound insurmountable, but it's only 6% of the land area of the world. And if we can plant that many trees, 7 billion people working to plant that many trees, we could reduce the magnitude of climate change quite a lot.
Thank you, Dr. Hellmann.
Thank you. All right, we're going to do a little reorganizing here, Madam Chair. I'm going to invite my colleague, Dr. Jason Hill, to join me. And we're going to switch gears. Madam Chair and committee members, we're going to talk for a bit, Dr. Jason Hill and I, about confronting some of the climate impacts and sector-specific impacts that we've been discussing. We've already begun this conversation in part by talking about carbon sequestration and other forms of adaptation. We're going to delve a little deeper into that. I'm going to start, and then I'm going to hand it over here to my colleague. So how do we address the impacts of climate change? And many of the impacts we've been discussing the last several days, ultimately we need to reduce greenhouse gas emissions, and that is in the electricity sector, in buildings, in transportation, in agriculture. This is familiar to many of you. I know you'll be working on these issues over the coming session. This is what we call mitigation. Much of it is about an economic transition. A main motivation for mitigation is avoiding climate change, but there are many side benefits such as economic development opportunities, cleaner air, and other sustainability practices. But mitigation is only part of the climate change challenge. The other portion is about living with climate change, and we call this adaptation. Even if we stop greenhouse gas emissions today and never emitted another molecule of CO2, methane, or nitrous oxide, the climate has already warmed and will continue to warm. Exactly how much it will warm depends on the amount of future greenhouse gas emissions we release. And we talked about those alternative scenarios of future emissions already. So it's a sort of choose your own adventure, if you will. So adaptation are all those adjustments and changes that we will make to social, ecological, or other systems to reduce the impacts of climate change best we can. On this slide, I reference it in 2017, our state government released an interagency report about adaptation across Minnesota, and a link to that report, committee members, is in the annotated notes of that slide. Globally, investment in adaptation is considerably smaller than investment in mitigation. The data on this slide are for public investments by national governments, but less than 20% of more than $130 billion was being directed to adaptation projects in 2013. We don't have these data from Minnesota, but we'd expect it generally to follow the same pattern. Now, knowing that adaptation is important is one thing. Thinking about how to do it in a smart way is another. There are better and worse ways to go about doing adaptation, and I want to share two examples, both of which have come up at some point. First is, let's talk about heat waves. Air conditioners can reduce heat exposure, but if they're connected to fossil fuel energy sources, they can also be a source of greenhouse gas emissions. Green roofs and urban trees also cool the city, but they do not release greenhouse gases, and they have other benefits. In Chicago, for example, colleagues and I found that green roofs could reduce a summer heat wave by 5 or 6 degrees Fahrenheit, and that difference can save lives and reduce energy demand. Here's another example. Consider the growing need for agricultural irrigation during future bouts of summer drought. One strategy for increasing water availability for irrigation is holding it locally on the landscape and recharging groundwater through the strategic placement of wetlands. And this could be a more sustainable approach. It doesn't work everywhere, but a more sustainable approach than relying on non-renewable aquifers for irrigation water source. An idea very closely related to adaptation is something we call resilience. Resilience is about making a system, a human system, a natural system, robust to stressors or to shocks, so that rather than converting to a degraded state in response to a disturbance, that system returns to a healthy status. And this resilience is something that we can work to build or increase. Often, it is the case that resilience is ultimately limited, however, and large climate change can overwhelm resilience that's in place. So strong climate change could push a system from one healthy state to another state entirely. So a farm, for example, experiencing multiple years of drought and low yields might be abandoned, or fire frequency in a forest might grow so much that it isn't a forest anymore and converts to a grassland. We do know several things about how to build resilience. We know that diversity in ecosystems increases resilience. This is actually quite well-known work that happened here in Minnesota, ecological research that showed if you increase the number of species in a grassland ecosystem, it makes that system more resilient to drought events. And that's shown here on this figure on the left-hand side. Drought resistance is a function of the number of plant species in different experimental plots of grassland. A similar phenomena exists for diverse economies, where diversity helps withstand economic or environmental stresses, including natural disasters and climate change. And strong social networks and investment in public infrastructure can enhance social resilience. Now, there are costs, sometimes considerable costs, to every mitigation and adaptation action that we take to address climate change, but there are usually side benefits to those actions too, or what we call co-benefits. This cartoon pokes fun at the criticism of addressing climate change when that criticism fails to recognize those co-benefits. Co-benefits include things on the mitigation side, like the fact that electric cars can be plugged into renewable energy, mitigation, but they're also quieter and don't release asthma-causing particles. There are co-benefits of plant and animal conservation if we were using wetlands to increase water for irrigation, for example. And there are co-benefits of creating stronger communities that are resilient to heat waves or storm events. Another important thing to consider about climate change here in Minnesota is a function of what we call indirect effects. Indirect effects are those consequences beyond the obvious ones, where climate change affects something that then affects another thing. We tend to focus on how much, for example, it's going to rain or how hot it's going to be, where we live, and how it will directly affect the things that we care about in this state. But also remember that the effects of climate change are happening elsewhere around the world as well, and those impacts affect us indirectly. In this slide, I'm suggesting consider sea level rise and coastal flooding, or increased fire risk that's more pronounced in other parts of the country than here, and these factors may make the upper Midwest relatively more desirable, creating an indirect effects that could be demographic or socioeconomic in nature. And those changes are both an opportunity and a challenge, business resettlement or migration, for example. And lastly, I'd like to leave you with a tool to consider when evaluating both mitigation and adaptation. We have spoke this morning about these different scenarios. How much greenhouse gases will we emit into our future atmosphere? We use those scenarios to compare and contrast and to see what different possible futures might look like. And we all tend to use the same set of future greenhouse gas emission scenarios. And that's a useful tool when we are looking at different future possibilities. We do the same often when we're making demographic or economic projections. We look at different scenarios of what the future could hold because we're not sure exactly what the future could hold. And we can do the same when thinking about mitigation and adaptation policies, is to think of them in a scenario framework. So here's just a cartoon that imagines a hypothetical set of scenarios under, say, increased temperature and population growth. And when we imagine a policy to address those issues, we can ask, is this policy specific to only one of these future scenarios? How likely is that scenario? Would this policy have benefits across multiple scenarios? And what are the co-benefits in those scenarios? So next, I'd like to turn the slides here over to my colleague, Dr. Jason Hill from the Department of Bioproducts and Biosystems Engineering. He's going to take some of these adaptation ideas and show us some concrete examples from the agricultural sector.
Thank you. Madam Chair, representatives, my initial charge in this, as you can see from the agenda, was examples of adaptation across economic sectors. That was a massive charge, to say the least. And so based on some of the initial feedback we received and the interest that was expressed by this committee on agriculture in the hearing on Tuesday, we decided to focus this really on agriculture as a specific example. And what I'm hoping to do is to give you a little bit of an idea about how I would go about approaching thinking about adaptation within a specific sector, what sort of forces are at play, and what sort of opportunities there may be both for adaptation as well as mitigation. At the end of what I have to say, I'm going to give you a specific example of a win-win-win solution, both for agriculture, the public, and for well, something I will reveal at the end as well. Agriculture is a continually adapting sector. Farmers continually adapt what they do on short, medium, and long-term scales. I grew up in part on a farm, and I've experienced a lot of this in my own life. Early in the spring, depending on how long of a growing season is expected, farmers change the maturity of the corn that they plant. Will it be harvestable in 75 days, 80 days, 90 days? They make those decisions, and within a week can easily change what they plan to do. On the medium term, rather than planting corn that year, they may plant something else. An example from the STRIB from last week, more wheat is being planted in Minnesota. Now the corn and soy prices are lower. Farmers make that sort of change. Back in the late 1800s, 150 years ago, 70% of the state's agricultural land was planted to wheat. Farmers make these changes based on demand. And then finally, I gave you a picture of a vegetable tikka masala. Long-term trends in dietary change also affect what farmers plant, what they produce on their land. All these things come into play. Farmers adapt what they grow, what they plant, where they invest based upon these sorts of forces. And agriculture will need to adapt not only to these sorts of things that have happened in the past, long-term trends and demographic changes, population, dietary preference, and so forth, but climate change adds one more thing for them to consider. The sorts of things that you've heard about today and on Tuesday, about the sorts of challenges that will be faced, not only in the specific changes in temperature and the impacts of that on agriculture, but also in uncertainty. Farmers need to make investments. They need to decide whether to take jobs off the farm, other employment. Those sorts of things come into play, and they're compounded by the challenge that climate change adds. Adaptation should be considered not only for the benefit of farmers, that's certainly tremendously important in all this, but also for the public. Public has an interest in clean water, in clean air, in not emitting additional greenhouse gases. And so adaptation is going to be, is ideally set so that it's considering both the needs of the public and farmers at the same time. In some cases, in the example of irrigation that Dr. Hellmann gave earlier, there is the potential to use, say, long-term water stores to tap into aquifers for short-term benefits, where that may be in the public's disinterest, but there may be other options, such as storage of water on land, that may both be in the farmer's interest as well as the public's interest. And one of the things I would like to leave you with today is that climate change really provides us with impetus, provides us with impetus to make the sort of changes to our agricultural system that we should be considering even without climate change. There are all sorts of benefits that we can see from changes in diversification of landscapes, for instance, in different practices that can be mutually beneficial to the public and to the agricultural sector. There is also the potential, and this is the third benefit that I spoke about, there's the potential to tie adaptation to mitigation as well. This is the state soil, the Lester, and the rich soils that we have in Minnesota that make us so productive, that make us somewhat resilient to climate change relative to other states that you heard about in the first talk today, are a function of the history of the prairie and the sorts of species that provided carbon sequestration, formation of soils, that gave us what we have today. And in conventional agriculture, a lot of that carbon has been lost to the atmosphere. There are opportunities, say through diversification, through planting of perennials on landscape, through other agricultural tillage practices, to actually turn that around, to start restoring carbon on the landscape, both adapting the system to be more resilient to climate change, as well as a mitigation opportunity of carbon itself. So finally, I'd like to talk about a specific experiment. This is the Marsden Farm experiment at Iowa State. I work with Dr. Matt Liebman down there to understand some of the environmental and economic impacts of diversification of agricultural systems. This is an experiment that went in around 15 years ago that looks at adding additional crops to a traditional corn-soy rotation. Most of the corn and soy grown in the U.S. is grown in this 2-year rotation. And the experiment itself added additional crops. So rather than a corn-soy rotation, there's also a 3-year rotation where oats are added to the mix, and a 4-year rotation where alfalfa is added. So we're still producing, the land is still being productive every year, but it's also, producing different things. And my final slide here, I was told this should be somewhat graduate seminar-like in my presentation today, so I'm giving you a couple figures here specifically on that. On the left, this radar chart shows some of the outcome of the 2, 3, and 4-year rotations on different impact categories. So you see at the top is soybean yield. To the right of that is maize yield. And you see that in all of these systems, the 2, 3, and 4-year system, you're producing just as much soybeans when you're producing soybeans, just as much corn. You are reducing, so freshwater toxicity, herbicide, synthetic nitrogen inputs, all to the right of that. You are greatly reducing the synthetic inputs that have to go into these systems, and including fertilizers and pesticides and so forth, much less damaging to the water. But then when you look at the left-hand side of this, you see that profitability is the same in the 2-year rotation, 3 and 4. You are maintaining profitability to the farmer while diversifying the landscape and greatly reducing the environmental impact. In a paper we published just last week, we saw that nitrogen pollution runoff from the system overall is reduced by 40%, phosphorus pollution reduced by 30%, and erosion by 60% from these systems, while still maintaining the same level of profitability for farmers. And on the right is some results that we just derived last week. You're seeing these before these have even been published. These are emissions of carbon dioxide from the 2, 3, and 4-year systems. And you see that emissions of greenhouse gases are greatly reduced by about half or more in the 2 and 3-year systems, while again maintaining the same level of profitability for farmers. So this is just one example of the sorts of options we have available to us to benefit farmers in adaptation to climate change, as well as offer potential in mitigation. Thank you.
Madam Chair, we have a few moments for questions. I know you have a lineup already.
Yes, we have some lined up already, and we'll be.
And I invite my colleagues, if there are questions for them, to pop back in, of course.
Representative Hornstein.
Thank you very much, Madam Chair, and this was a great presentation, so I want to thank you both. But my question is actually for Dr. Keeler. It was from the last round. So.
He's done it already.
Dr. Keeler, you had touched on planning and zoning policy changes as potentially very impactful for mitigating the impacts of greenhouse gas emissions on cities. And I seem to recall at the legislature's instruction, I think it was either the Humphrey School or the Center for Transportation Studies did a study, 7, 8 years ago, I believe, on the topic was how do we reduce greenhouse gas emissions from the transportation sector? And, the conclusions were, clear. I mean, transit, clean cars, electric vehicles. But there was a third one that I think deserves a little bit more attention, and you had touched on it, and I'm wondering if you can expand on that. It was land use planning and land use changes. And if you could just maybe talk a little bit more specifically about that, I think it would be helpful.
Great, thank you, Madam Chair and members. So yeah, the way that we manage our land has a big impact both on the emissions of greenhouse gases because of the way that we use land and associated emissions with different land uses, whether it's residential, commercial, industrial. But our landscapes also can provide a buffer against climate impacts. So one example of that would be ways of protecting floodplains or implementing other types of green infrastructure that help to absorb heavy precipitation rain events and help improve recharge. We should be thinking about the impacts of zoning that allow for increased precipitation events that might lead to flooding in areas that we see persistent flooding. Maybe those are areas that we don't want to have high impacts in development in those areas. We want to protect them and allow them to stay in a type of vegetation that allows for recharge. So I think there are a lot of things that we can do with respect to both increasing the amount of what we call green infrastructure, which is provides a buffering capacity and helps not only to mitigate and sequester carbon, but also reduce impacts of rain events, and then protecting areas or moving development out of certain areas that we think are going to be subject to flood risk.
Thank you.
Representative Halverson.
Thank you, Madam Chair, and I think we're all asking questions from our background and issue areas. It's so interesting, the experience that sits around this table and how much this presentation has hit on so many of our issue areas. And I'm particularly interested in public health, so I had a question for Dr. Surapaneni, if you want to come back. Thank you. And I actually thought about just holding this question because in light of the presentation that we've just seen, wanted to, I'm certainly sure that there will be having questions about that because of what we can do. But hearing your comments at the end about runoff in agriculture and the way that we can mitigate that, and then seeing how global climate change really is going to have an impact on runoff. The slide that you showed us had a notation, had a citation regarding a study about blue babies and nitrates, and I was wondering if you could talk about that a little bit. It's something I've heard about in Minnesota a bit, and wondering about what that is. It certainly jumped off the page at me, and what the impact is, because this is one more area where we're seeing a lot of increase in the cost of healthcare in Minnesota.
Yeah, absolutely. Madam Chair, committee members, thank you for the question. So like you said, with agricultural runoff, you're going to see more nitrates in the water. And if you use that water to, the cases that we have seen, people used it to reconstitute baby formula. So whether it's well water or local water that they're using. And infants don't have the capacity or the enzymes to process those nitrates. And so,
Excuse me for a minute.
Yeah.
Can you just speak a little closer to the microphone?
I'm sorry. Yeah, so with the agricultural runoff, nitrates end up in the well water, and particularly in farming communities, when you use that contaminated water to reconstitute baby formula, infants don't have the capacity to process all of those excess nitrates in the water, and that can prove fatal to them. That's what it's called blue baby syndrome, yeah.
Madam Chair, I appreciate a little more clarity about that because, like I said, it really jumped off the page at me. And I think, transitioning to the next set of slides that we got to see, it sounds like there are things that we could really be working on right now to not only mitigate, talk about your dual benefits, not only mitigate impacts regarding global climate change and making sure that our agricultural communities can continue to thrive, but that we could save babies. I mean, that's kind of remarkable. So thank you.
Representative Swazinski.
Thank you, Madam Chair. And just was kind of just a question, kind of talking like a little, you mentioned a little bit about emerging markets and just kind of looking at emerging markets and then the increase of kind of the wages in emerging markets and then the increased consumption of proteins in there. Maybe this would be for Mr. Hill and just kind of what are your thoughts on that and it's what you would perceive as its contribution into the subject matter?
Sure, absolutely. Madam Chair, representatives, yes, as incomes increase, one of the first things people do is they buy more meat. They increase increase protein consumption. And certainly Minnesota has been a major provider of protein, both to the U.S. and to the world in the sorts of things we grow and produce. Most of the corn and soy we grow goes into animals, and most of those animals are certainly eaten for meat. There are other ways to produce protein. In fact, it's much more efficient to produce protein from non-meat sources on the landscape. When you produce protein from animal protein from vegetable protein, only 1 part in 20 of plant protein is converted to animal protein in cattle, and it's a little better for pork and poultry and so forth. But one of the changes we should be thinking about when we think about global trends and ways of adapting and mitigating in Minnesota is diversifying our landscape so that we see these environmental benefits as well as see the health benefits of eating more diverse, more plant protein rich diets. And so it's not as though we need to continue supplying the world with corn and soy for more meat, which especially red meat has primarily negative health outcomes, but we can provide either other types of animal protein or plant protein that can still, as we've seen in the presentation I gave, can provide protein and yet still maintain profitability for farmers.
Did you follow up?
Yes, thank you, Madam Chair. I've got a couple more here too. So obviously you guys have bigger degrees than I do. And just kind of from a carbon-free standpoint, where do you think, obviously we have a population growth and I think they're talking by in the next 20 years, potentially 8 to 10 billion people here on the earth. What do you think, just a population model from a carbon-free standpoint is in your view sustainable and how do you get there?
Madam Chair, committee members, I think it's a terrific question. It's basically a balancing problem, right? Carbon in, carbon out, where is it coming from and what are the different sources? And it's not only carbon. So just to make sure it gets said, if only for my own clarity, when we talk about greenhouse gas emissions, there are 3 major components: carbon dioxide, CO2, methane, CH4, and nitrous oxide are our 3 components. We say carbon, we're actually not talking about the nitrous oxide component. Then there are a variety of other greenhouse gases that contribute but are relatively minor players. So most of the time when we think about how do we address climate change and greenhouse gas emissions, we focus on those 3. And then those gases come from a variety of different sectors. And we've made quite a lot of progress in CO2 emission reduction in the energy sector, for example, such that now transportation, to Representative Hornstein's point, and agriculture are emerging as higher priorities, in part because of progress we've made in other sectors. And in those sectors, especially in the agricultural sector, it's less about CO2 emissions and more about methane and nitrous oxide emissions. So when you think about how many people are in the world and what food crops need to be produced and what those diets are, you ask where in the world are they produced, what are the greenhouse gas emission signals of them, and then what accounting is going to be done for those emissions. So strategies such as carbon sequestration are important. There are other methods, digesters, and other ways of coupling systems so that you can take resources that are produced in one system and maximize the utility of that to reduce the total greenhouse gas emissions and other kinds of strategies. But it is essentially a calculation. And if you take 10 billion people and you feed them all red meat, there's no way you will meet the Paris Agreement or any other less than catastrophic warming event. And that's a reality that we need to confront. Jason, you probably could say more about.
Madam Chair, Representatives, just want to add that about 2/3 of global climate emissions are from fossil fuels and about 1/3 are from food, the agricultural system. So we need to address both of those if we're going to truly see the benefits that we would hope for.
Yeah, Madam Chair, if I could add, my colleague here has just pointed out a great paper that came out recently, which we'd be happy to share with you, that actually makes this sort of make it fit argument, that does this calculus and shows methods by which you could feed that 10 billion people and stay within some of these more moderate climate targets. So I'd be happy to share that paper with the committee.
If you send that link to us, we will share it with the committee. We have a couple of more questions in just a few minutes. Representative Purcell.
Thank you, Madam Chair. I was going to ask a question if anybody knew how to farm like we did in the 50s and early 60s, and I got the answer by this Marsden experiment. I remember that before chemicals, and so it can be done. And I don't know if it's worth talking about Back to the Future, but that might scare some people. But I just offer that as an observation.
Thank you. Representative Christensen.
Madam Chair, thanks, by the way, to the panel. This has been fascinating. I have a question about, I know diversification of crops is something that we should be looking at. Can you talk a little bit more about perennial crops? What kind of, especially in Minnesota, what kind of perennial crops would be advantageous and would be lucrative, or, that farmers can actually grow and be successful?
Okay.
Yeah, Madam Chair and Committee, thank you. And if Jason has anything to add as well. There are a variety of forms that perennial crops can take. I mean, obviously, our orchards, there are some hazelnut, crops in production. And so, that's a pretty major direction that we could go more in, but there are also several perennial grain crops. There's a kind of lesser on the scene is a perennial barley that's in development, but there's also a perennial wheatgrass. It's called Kernza. I'm not sure if many of you have heard of that yet. There's like a popular beer that Patagonia has made out of it that has hit some buzz on occasion. And so this is a wheat-like grain crop that has many potentials. It could be an economically viable crop to plant in kind of these sensitive wellhead protection areas. Our team has a new LCCMR project looking at that specifically right now. We've planted it in some wellhead protection areas in the state to see if we can improve nitrates in groundwater and some of these issues. And it still has the grain that you can harvest as well. It also offers some potential as a dual use crop. So another one of our experiments is looking at, if we graze it in the early spring and after harvest, you can get animals on that land, but you still can have a viable grain crop. So this is one example of an up and coming success story with these types of crops. There's still a lot of agronomics to work out. We're still, the only farmers planting it right now are the kind of experimental early adopters that we really appreciate, but we've been hitting all the sectors. How do we breed it better? We've been working with General Mills of how to create products that are marketable. So, and for me personally, as a soil scientist, it's been really interesting to see how do you develop a new crop that can meet all of these societal needs, from the economics to the environmental quality. So that's a case study that I specifically have been working on. Did you have something to add, Jason? Okay.
We have time we're about out of time. We have two folks on the list. If you have very quick questions, Representative Bierman and Representative Swazinski. Yes, if you have a quick question.
The question I had, let's see, was on, with Professor Hill. You had mentioned all the advantages of the environmental changes that could occur and the economics being there. So how do we go about getting that out as a program? Because it seems to me good economics and productivity and production and yield and all of these things in agriculture really can be the driving force for that. And we can, at the same time, reduce perhaps some of the nitrates going into the water. And as a follow-up, I'm wondering what other things, I hear constantly about nitrates, but I don't hear about any other chemicals that are really high on the list or that is talked about much. I'd like to have a comment on that too, please.
Madam Chair, Representatives, I'll answer your second question first. Nitrate is certainly important, but there are other consequences of agriculture as well. A major one is ammonia emissions that lead to fine particulate matter formation in the atmosphere, which leads to premature mortality, early death. In fact, about 100,000 people in the U.S. each year die early because of fine particulate matter in the atmosphere. About 15,000 of those deaths are from agriculture. So there are things that we can do to reduce ammonia emissions, changing fertilizer types, for instance, injection of fertilizer rather than broadcast can greatly reduce those emissions. So that's just one example. And I'm sorry, your first question, really quickly?
We have just.
How do you get people to do this? The coordination problem of bringing farmers in. So there are many things that can be done. One of the things to consider especially is finding ways to sort of monetize these sorts of benefits and then incorporating them into either the cost that's paid, the burden of doing things wrong, or a premium, a benefit of doing things right. And that can be borne by the consumers. It can be borne by the public, either in forms of taxes or incentives. There are all sorts of ways of bringing about these changes. But the key is to look at what agriculture delivers, not just as productivity, not just as the quantity and quality of the product that comes off the land, but to look at all the other services that agriculture either provides or disrupts, and then finding ways to incorporate that into the equation that needs to be considered. That requires the public, it requires consumers, it requires businesses all to come together to find some system that takes that into account.
Representative Swazinski has the last very quick question.
Thank you. I'll be very brief. Just it talked a little bit about dust. Thank you, Madam Chair. There was last year the MPCA moved some potential rules forward talking about fugitive dust. I just wanted you to touch about that and what your thoughts were about moving policy like that moving forward.
Madam Chair, Representatives, I'm not entirely familiar with the specifics of that, but fugitive dust certainly contributes to a fraction of that is this fine particulate matter that leads to premature mortality. Dust is not only a problem for health, but it's also loss of a valuable resource on land itself. So by reducing dust, you are maintaining the soils, maintaining the quality of the land itself, and you're seeing all these other co-benefits of having cover on land at any given time.
Madam Chair, may I make one really quick final comment? Just for the record, I feel like though we've spoken now for multiple hours with all of you about climate and climate change and co-benefits and adaptation, there's a lot we didn't talk about, and I just feel like for the record, we didn't talk about, and we could have brought some university experts on how does climate change affect Lake Superior, or how is climate change influencing critical resources like wild rice, or affect the flow of goods and services in the global supply chain in our state. And given the opportunity, we'd love to come and talk more with you about any of those things. So thank you.
Thank you for what you have done. It's been incredibly informative to us. I know it took a lot of work. We have never had such detailed notes attached to slides before, so I understand the work involved in that. They are posted on our website. We will keep them up there for the duration so that we can use them as a resource, so the public can use them as a resource too, because we're going to be obviously moving forward on lots of things that will help Minnesotans both reduce the climate change gases and adapt. So working together, I think there are a tremendous number of opportunities. We're just going to have to find the ones that are best and can move us the quickest. So with that, I will tell members that next week, we are going to hear from PCA on the sources of climate change gases in Minnesota, and then do a deeper dive into the air quality report that you all did talk a little bit about, but we're going to do a deeper dive into that. That is on Tuesday. On Thursday, we're going to learn about the electric grid, take a very deep dive into that. And so with that, members, thank you once again. We really appreciate all the work you've done and all the help you've given us. Meeting is adjourned.